2014 Leaving Cert High Level Sample, Paper 2, Question 6B. We're looking at a triangle with various different lines drawn, altitudes of BE and AD perpendicular to the bases, and we're asked to look at the angle of DOC, well, is equal to DEC. Let's go through formally the process of being able to prove. You should always think about what you've been given. In this instance, we're given the fact that angle ODC and indeed OEC are 90-degree angles. We need to do a little bit of construction. We need to construct effectively what we're wanting. We're wanting the angle DOC, so for that I need to draw a line from O to C, and we're after angle DEC, so I need to draw in the line segment DE. The third step in any proof is to just simply state what you're asked to prove, and this is angle DOC is equal in size to angle DEC. Moving on to the fourth step, which is actually just the proof. And the key thing about the proof is to look at the quadrilateral OECD. And we look at the angles of OEC and ODC, which are opposite each other, and they're both 90 degrees. And in this quadrilateral, those two angles are opposite and summed to 180 degrees. Then if we were to look at the other two angles in the quadrilateral, so EOD and ECD, and we find these angles are also have a sum of 180 degrees. This is primarily because we know any quadrilateral has a sum of 360 degrees for its four angles. And as a result of these two facts, we have a situation where, because both pairs of opposite angles sum to 180 degrees, we have a situation where my quadrilateral OECD is a cyclic quadrilateral. Meaning all four vertices O, E, C and D are on the circumference of a single circle. This will now move us on to being able to look at the two angles that we were asked to look at, which is DOC and DEC. These two angles in here. If we simplify the drawing, just looking at solely what we want to look at, which is the circle and the points O, D, C and E, we can see with this shared chord, or you could even talk about this shared arc, minor arc, DC. And we're now going to use corollary 2 of theorem 19, which basically states that all angles at points on a circle standing on the same arc are equal. So what we're saying basically in this instance is we have angle DOC in size is equal to angle DEC. As I said to you, the reason for that is theorem 19, corollary 2 of the syllabus.